Okay. Okay. Hi, everyone. As Ray mentioned, today we are going to talk about performance tools and debuggers. This track is organized by myself and Scott Parker. Okay, let me move on. So, what is your favorite debugger? Many users just use a printf statement, right? So this is very useful debugging tool, but on HPC environment, it's not really a good way to debug your code. So you can have a better debugger on HPC environment, and this track we will introduce several very powerful debuggers on HPC environment. And how do you measure your performance of your application on HPC? So probably you will just measure work time, right? Time.a.ot. This is the easiest way to measure your performance. Or maybe you measure flop rate or the memory bandwidth. But after measuring that, if you find out, oh, your kernels has very low flop rate or low bandwidth or very slow work time, what do you need to do? What do you do? So we need to identify what is the performance bottleneck on specific platform, right? So maybe your application works fine on the CPU, but may not work fine on the KNX system or GPU system, right? In this case, you need to find the what is bottleneck. For that, the leading profiling tools can help you optimize your code on HPC environment. So there are so many profiling tools and debuggers out there. So we chose 7 powerful HPC tools in this track. And those tools are available on most of the DOE HPC center system, include NSF center system. So first group is hardware vendor tools. So in this group, we have Intel BTO Advisor for Intel platform and NVIDIA Inside Compute for the NVIDIA platform, and the AMD ROCm tools for profiler and debuggers for the AMD platform. They know their hardware very well, and they know their software stack very well. So their tools are very well optimized for their platform. But the weak point is those tools are only available for that platform, not the other platform, right? So you cannot think using the NVIDIA Insight on Intel VTune on the NVIDIA GPU, right? So there's a weak point. So because of that, we have the second group, the cross-platform tools. So those tools are available across platform. So ARMForge, DDT is a debugger, and that is profiler. And Purpose Total View, this is a very powerful debugger, which is available on the multiple platforms. So if you are thinking of using multiple platform, you may need to look into cross-platform tools. One thing is these tools are not free. So you need to purchase a license. So because of that, we have the third group, open source community tools. They are also available across platforms. And we have HPC Toolkit and Tau. Both of them are very powerful and very useful tools for HPC environment and your laptop. This track, we have several major contributors. So myself and as Ray mentioned, Scott is the co-organizer of this track. I think Scott is in this session now, right? Scott, do you wanna introduce yourself and provide some history of this track?
Sure. Yeah. So my name is Scott Parker. I've been with the ALCF sort of since the beginning, which is about 12 years now, and part of the performance engineering team. And over the years, we've worked with pretty much almost all of these folks on various platforms. And we're fortunate that JaeHyuk was able to wrangle all these speakers here, and we were able to get them to all participate today. And I think we have a great coverage of the the tools that we've seen people using on the major HPC platforms over the years. And I'd really like to thank the speakers for taking the time to participate in this, because I think it's a great opportunity for folks to get familiar with these tools, because they can be a bit complex. And performance tools is not one of those topics that people are going to master in one day or even 1 week, or in some cases even 1 year. But this is a great opportunity to try things out and ask questions. And so I'd really encourage folks to take an advantage of the opportunity to talk to speakers and to try things out during the hands-on sessions. They're not long enough that you're going to be able to do, a thorough analysis, but it's a great chance to, fire up the tool, see if you can get it working for your code and try and do something simple. And I think if you can get that far today, then, you're well on your way to being able to do more with them. And it's often that first step that can be the hardest. And it's great to have someone to ask questions and help you with it. And so I really encourage you to try it out and ask questions of the speakers. So JaeHyuk, yeah, I'll turn it back over to you.
Okay, thank you. Yeah, and on the hardware vendor tools group, we have 3 vendors, right? Intel, NVIDIA, and AMD. And Kevin will lead Intel tools. Kevin, do you want to introduce yourself and talk about your session briefly?
Sure. My name is Kevin O'Leary. I've been at Intel about 16 years. I work in Intel's Performance Tools Group, mainly supporting vTune, Advisor, and Inspector. I was one of the original developers of Parallel Studio, and I'd just like to reiterate what Scott was saying. Any questions you have, the first session is fairly short, but you can always reach out. It's really my pleasure to come in and introduce you to the tools. So, okay.
Okay, thank you. Max, do you want to introduce yourself?
Hi, Max Katz here from NVIDIA. I serve as the technical consultant liaison for DOE users at centers like Summit, Perlmutter, Argonne, that sort of thing. And I'm going to present the NVIDIA Nsight Systems and Nsight Compute tools, primarily focusing on a demo showing you how the tools work. And then in the hands-on exercise, you'll be able to complete the demo and try the tools out yourself.
Okay, great. Thanks, Max. Siash, do you want to introduce yourself?
Yeah. Hey, everyone. I work at AMD Research, and my primary goal is performance optimization of HPC applications on AMD hardware, so CPUs and GPUs. Today, I'll be introducing the ROCm tools that I think are more important for the architectures that are coming up. So basically, the ROCm Profiler and the ROCm Debugger. And I'll be showing a live demo and probably extending that in the hands-on session as well. Fun fact, I'm an ATPESC alum. So last year I was on the other side of the aisle. I was attending the talk. This year I'm the speaker, so it's a little funny.
Yeah, welcome back. Okay, so the second group is
the student becomes the master.
Yeah, we need to think. Yeah. Okay, so second group is cross-platform tools. One is ARM Forge, and the other is Purpose Code Review. Ryan, do you want to introduce yourself?
Yeah, hi. Name is Ryan Holgan. I was originally part of the Alinea support team, but of course, Alinea got acquired by ARM, so now here I am with ARM. I focus primarily on the ARM Forge tools, HPC tools, mainly the DDT debugger and map to profiler. But I'm also expanding into the ARM compilers as well for ARM hardware.
Okay, thank you, Ryan. Nikolai, do you want to introduce yourself?
Yes, hi, can you hear me?
Yeah, I can hear you. Yep.
Yeah, I switched to another computer. So my name is Nikolai, and I'm working with Total U Debugger for already probably 20 years. So I was original team from Total U Technology, which was acquired a couple of times, and now we're part of Perforce. Yeah, I will be introducing Total U Debugger. Have very ambitious idea, so I don't know if 35 minutes will be enough, but I have head-ons and I have a labs to present, and hope you will like our debugger.
Okay, sounds great. Thanks, Nikolai. And the third group is Open Source Community Tools Group, and John Mellor-Crumney for the HPC Toolkit, and Samir Shender for the TAO. I don't think they are in the session now, so we can skip the introduction. And they will, their sessions are the last session, so we will have, do we have John or Samir? No, right? Okay, so we will have a chance to talk with them this afternoon. Okay, so thanks for your contribution, all speakers. And yeah, this is our team. And as you see, in the morning, we have hardware vendor tool session for Intel, NVIDIA, and AMD. We will have the sequential the talk, and then we will have the parallel hands-on session, so room B and C and D, right? And then in the afternoon, we have a cross-platform tool session. So we will have the total review, ARM and total review talk in the main room, and then we will have the parallel hands-on session for on room B and C. And then we will have open source community tool sessions. So HPC Toolkit and Tau talk in the main room. And then we will use the breakout room for the parallel hands-on session. I believe you guys already know what is Zoom session because we're in, and we will use the breakout room. So if you click the breakout room on the bottom, you will see the room B and C and D. So we will use those rooms for the hands-on session. And as Ray mentioned at the beginning, we have we created the Slack channel for specific tools, right? So for the Intel tools, you need to, if you leave your question or your question in the track 6 breakout Intel, Kevin watch this channel and give answer very quickly. And for NVIDIA, we will have track 6 breakout NVIDIA. So Max will watch this channel. And for AMD, we will have track 6 breakout AMD, and Siash will watch this channel to answer your question. So please join this channel to ask questions. And for cross-platform tools, we have track 6 breakout room ARM. So you can leave any question about the ARM tools, and Ryan will watch this channel. And track 6 breakout room purpose, this is for the total view debugger. So Nikolai will look into this channel to answer your question. So please join it. And last group, the open source community tool, we have track 6 breakout HPC Toolkit, and John will watch this channel, and track 6 breakout Tau. Samir will watch this channel to answer your question. So please join those channels and leave your comment or questions about the tools, okay? And this is the last slide. So system for hands-on. We have 512 data reservation from 9 a.m. to 6 p.m. on Central. So as you know, you use this queue and this project. We have 80 nodes on Cooley and 21 full nodes on Theta GPU. And if you didn't have chance to get the full Theta GPU, you may use single GPU queue. So instead of training queue, and then you can get only one GPU instead of full nodes. So you can reach out to me about the instruction about that. Intel Dev Cloud, I believe you guys already joined the Intel Dev Cloud, so you probably get a very detailed instruction how to use Intel Dev Cloud. So once you access the Intel Dev Cloud, you can just use this line, qsub-i load 1 and GPU ppn2-d1 dot, and then you will get one of the Intel Gen 9 GPU to practice. AMD Accelerator Cloud, we have a total 40 MI100 GPU. So we assign 2 users per 1 GPU. So if 2 users are using the GPU together, you may see some performance regression, but we unfortunately couldn't get 80 GPU. So please understand the situation. And for the instruction, you can see this box folder. And yesterday I shared, I sent your login credential to through Slack DM, so you should have that information. So if you don't have it, just please reach out to me and I can fill it out. And Accent is also a very nice NVIDIA V100 resource, right? You don't have reservation, but you can just use default queue with this project code, and you can use the NVIDIA V100 GPU from the Accent. So I think this is all for introduction. I think I used 5 more minutes, so sorry about that. So yeah, thank you for joining this tools track, and yeah, enjoy.